So welcome to this video, and in this video I wanted to have a look at, have we actually imaged any exoplanets? So do we have any real images of exoplanets or not? Well, if we start with the solar system, we have fantastic images of most of our planets in the solar system. We've sent spacecraft to most of them, and we've got some really detailed images. So for example, we've got fantastic images taken of Jupiter by the Juno spacecraft, and similar for Saturn with the Cassini spacecraft. So we've got some fantastic images of planets in our own solar system. But exoplanets are planets around other stars. So these are much further away. So do we have any images of these exoplanets? Well, we do have some nice artistic impressions of exoplanets. So for example, this one here, these are impressions of what they might look like. So we've detected an exoplanet, and from what we know about it, where it sits, its size, there are some ideas of what they might look like. So there are some really good artistic impressions of what they might look like. But this one here is not real. So we don't have images of that much detail of an exoplanet. But what do we have? Well, if we go to the Exoplanet Archive again, you can plot all of the exoplanets that have been discovered so far. So this is a plot of the orbital period against the mass of all confirmed and discovered exoplanets. So it's about 5,000. And the colour of each marker on that plot denotes the method in which it was detected. Now, most are detected from the transit method and the radial velocity method, but there are a smaller proportion of other types, mostly because they're harder to detect them. And I've highlighted those that have been detected through direct imaging. So that green box there is planets that have been detected because they've actually been seen or imaged directly. Now, one thing you'll notice there is that they sit on a very particular part of that plot. So they are all more massive than Jupiter. They also have very large orbital periods. Now that suggests that they are large planets a long way from their star compared to the other detection methods. So we'll have a look at why that might be the case. So if we have a look at a star, they are obviously quite bright. They're emitting quite a lot of light. And if you have a small planet that is very close to that star, then it's going to be very difficult to detect. So the glare from that star will basically outshine any light that's coming from the planet. So the planet will reflect some light. We can detect that. But if it's next to a star, then obviously it's going to be very difficult to detect. And the bigger the planet, the further away it is from that star, the easier it's going to be to detect. So we move further away. We've got a big planet far away from its star. That then becomes easier to see. So a small planet close to its star is not going to be easy to detect. So that's why on that plot, most that we have imaged so far are big gas giants that are a long way from their star. So some examples of what we have imaged, and it is only a handful of planets that have been directly imaged. So here's one. This one is about 3 times the mass of Jupiter, and it's obviously a long way from its star. The central part of this image or this animation is blocked out, which would be the star. So in order to see the planets, you typically will block out the light, put a bit of a shield over the star so that it doesn't saturate your image. So now you can see that planet orbiting. And at the bottom of that animation, you can see 10 AU. Now 1 AU is the distance between the Earth and the Sun. So that gives you an idea how far away this planet is away from its star. So it's quite a distance from its star. And this was actually one of the first planets imaged by the Gemini Planet Imager. And now we have a system with 4 gas giants in. So these are, we probably refer to them as super Jupiters. These are very large gas giants, and they are a long way from their star. So again, 20 AU at the bottom. 1 AU is one distance between the Earth and the Sun. So these are a long way from their star. In fact, their orbital periods are hundreds of years, and they're very big. And to give you an idea of the distance they are from their star, Saturn's orbit is drawn on the bottom right for a comparison. So these are a long way out in their system. So big planets a long way from their star again. And here's another one. This one is 5 times the mass of Jupiter, and it's twice as far away from its star than Neptune is to our Sun. Again, it's all following the same theme because they're easy to detect. And then this one is quite a nice one. So this is a Sunlike star, and there's 2 planets here that have been directly imaged. One is 14 times the mass of Jupiter, and one is 6 times the mass of Jupiter. So these are very large planets. They're also so far away from their star that their orbital period is on the order of about 5,000 years. So they take about 5,000 years to go all the way around their star. So that tells you they're a very long way from their star. Now, we don't have any really good images, so the best images we have are these here. So it just kind of looks like a featureless circle, really, because they're still so far away, even though they are very, very big planets. So it's not just planets that can be found. Well, this is a planet, but it's still in the formation process, so they're still in a disk around its central star. So actually there's a couple here, but the one I've zoomed in on still has a disk around its planet. Now this is thought to be a moon-forming disk, and we can actually see it. Now this could be undergoing the formation of moons or exomoons around this exoplanet. So it's not just planets that can be found. We can find the disks around them, a bit like Saturn's ring, although the disks are different because this is where it's initially still forming, whereas Saturn's is not. And then we have this one here finally as well. So this is Fomalhaut B, and this was originally thought to be a large gas giant orbiting in this debris disk around its star. But over a number of years, so over about 10 years, it's actually expanded and got dimmer, and it's now thought to be an expanding dust cloud as opposed to a large gas giant. So we are able to image some of these objects in these systems, but there's not that many of them because, again, they've got to be very big and very far away from their star to be detectable. So thank you for watching, and if you enjoy, you can check out some of the other videos.